Ever wondered if humanity could transform a gas giant into a new home? Today, we are diving into one of the most mind-blowing concepts in space exploration, terraforming Jupiter. Join us as we explore the incredible science, speculative technologies, and futuristic possibilities that could turn the largest planet in our solar system into a habitable world. Buckle up for an epic journey through the cosmos as we unravel the mysteries of this gas giant and imagine what it would take for humans to conquer Jupiter. Let's get started. 1. The audacious dream, terraforming Jupiter. Imagine a world where humans have conquered Earth, Mars, and even Venus. What's next? Jupiter, the largest planet in our solar system, beckons. But how can we terraform a gas giant with no solid surface? The answer lies in human ingenuity and our limitless intelligence. The challenge of transforming Jupiter into a habitable world seems insurmountable. Its immense size, crushing gravity, and turbulent atmosphere present obstacles that dwarf our previous terraforming efforts. Yet, the stakes for humanity's future in space exploration couldn't be higher. Jupiter's vast resources and strategic position in the outer solar system make it a critical stepping stone for our species' expansion into the cosmos. As we explore the innovative solutions devised to tackle this monumental task, we'll uncover the potential of atmospheric mining, the creation of a habitable core, and methods for manipulating Jupiter's environment. These groundbreaking concepts push the boundaries of science and engineering, showcasing the remarkable capacity of human intelligence to overcome even the most daunting challenges in our quest to reshape worlds. 2. Harnessing Jupiter's atmosphere. As we set our sights on Jupiter, the first step in our audacious terraforming endeavor lies in harnessing the planet's vast atmospheric resources. Jupiter's atmosphere, a swirling maelstrom of gases, holds the key to unlocking the potential of this gas giant. Composed primarily of hydrogen and helium, Jupiter's atmosphere is a treasure trove of elements crucial for our terraforming efforts. These gases, which make up approximately 90% of the planet's volume, represent an almost inexhaustible source of fuel and raw materials. The abundance of hydrogen, in particular, could revolutionize our approach to energy production and propulsion throughout the solar system. But how do we tap into this atmospheric wealth? Enter the concept of atmospheric mining, a theoretical process that could transform our ability to extract resources from gas giants. Imagine colossal floating facilities, suspended in Jupiter's upper atmosphere, designed to separate and collect specific elements from the surrounding gases. These atmospheric mining stations would employ advanced filtration systems and molecular sieves to isolate hydrogen, helium, and trace amounts of other valuable elements like neon and argon. The technology required for such an endeavor pushes the boundaries of our current capabilities. Engineers envision massive intake vents that would draw in Jupiter's atmosphere, funneling it through a series of increasingly fine filters. High-powered lasers and electromagnetic fields could be employed to separate different elements based on their atomic properties. The extracted gases would then be liquefied and stored in reinforced tanks, ready for use in our terraforming processes or for transport to other parts of the solar system. One of the most promising applications of atmospheric mining on Jupiter is the extraction of deuterium, an isotope of hydrogen. Deuterium is a crucial component in nuclear fusion reactions, offering the potential for near-limitless clean energy. The concentration of deuterium in Jupiter's atmosphere is estimated to be 5 times higher than on Earth, making it an invaluable resource for future energy needs. However, the challenges of operating in Jupiter's environment are as immense as the planet itself. The intense radiation belts surrounding Jupiter pose a significant threat to both equipment and potential human operators. Any mining facility would require robust shielding to protect against the constant bombardment of high-energy particles. The planet's powerful magnetic field, while useful for some extraction processes, also complicates the design of electronic systems and communication equipment. Jupiter's gravity, 2.4 times stronger than Earth's at the cloud tops, presents another formidable obstacle. The increased gravitational pull would place enormous stress on any structures we build, requiring materials and engineering solutions far beyond our current technological capabilities. Additionally, the planet's rapid rotation, completing a day in just under 10 hours, creates powerful winds and storms that could potentially tear apart less resilient constructions. Despite these challenges, the potential rewards of atmospheric harvesting on Jupiter are staggering. By tapping into this vast reservoir of resources, we could provide the energy and raw materials needed to fuel our terraforming efforts not just on Jupiter, but throughout the solar system. The abundance of hydrogen alone could revolutionize space travel, enabling more efficient and powerful propulsion systems for interplanetary missions. 3. Creating a habitable core. As we venture deeper into the challenge of terraforming Jupiter, we face a fundamental problem: the absence of a solid surface. Unlike Mars or Venus, Jupiter lacks a terrestrial foundation on which to build our future colonies. This presents a unique challenge that requires us to think beyond traditional planetary engineering concepts. To create a habitable environment within Jupiter's atmosphere, we must construct an artificial core, a feat of mega-scale engineering that pushes the boundaries of human innovation. Imagine a vast platform suspended in the Jovian clouds, serving as the foundation for a new human civilization amidst the swirling gases of the gas giant. The concept of a floating habitat in Jupiter's atmosphere isn't entirely new. In 1976, aerospace engineer Robert Freitas proposed the idea of floating cities in the upper layers of Jupiter's atmosphere. These theoretical constructs would be massive structures designed to float at an altitude where the atmospheric pressure is similar to Earth's sea level. To bring this vision to life, we must develop materials and construction methods capable of withstanding Jupiter's extreme conditions. The platform would need to be built from ultra-lightweight yet incredibly strong materials, possibly utilizing advanced composites or metamaterials not yet invented. These materials would need to resist corrosion from Jupiter's atmospheric compounds, withstand extreme temperature fluctuations, and maintain structural integrity under intense gravitational forces. One potential approach involves creating a honeycomb-like structure filled with hydrogen gas. This design would provide buoyancy in Jupiter's predominantly hydrogen atmosphere while offering a robust framework for habitation modules, resource processing facilities, and energy generation systems. The construction process itself presents a monumental challenge. Given the impracticality of transporting massive quantities of building materials from Earth, we would need to develop methods for in situ resource utilization. This might involve harvesting materials from Jupiter's atmosphere or its moons, processing them in orbital factories, and then assembling the components in Jupiter's upper atmosphere. Maintaining stability in the face of Jupiter's fierce storms and gravitational forces is another crucial consideration. The platform would require advanced stabilization systems, possibly incorporating active buoyancy control and powerful thrusters to counteract atmospheric turbulence. Additionally, a network of weather monitoring stations and predictive AI systems would be essential to anticipate and mitigate the effects of Jupiter's massive storm systems, including the Great Red Spot. Energy production on this floating world presents both challenges and opportunities. While solar power would be less effective at Jupiter's distance from the Sun, the abundance of hydrogen in the atmosphere could be harnessed for fusion power. Alternatively, we might tap into Jupiter's powerful magnetic field to generate electricity, using principles similar to those of magnetohydrodynamic generators. The gravitational pull of Jupiter, 2.4 times stronger than Earth's, poses significant health risks for human inhabitants. To counter this, the entire habitat might be designed as a massive centrifuge, rotating to create artificial gravity comparable to Earth's. This would require precise engineering to balance rotational forces with the planet's natural gravity. As we overcome these technical hurdles, we can begin to envision a truly awe-inspiring sight, a floating city-state suspended in Jupiter's clouds, protected from the harsh environment by layers of advanced materials and force fields. This metropolis in the sky would serve not only as a testament to human ingenuity but also as a gateway to the outer solar system. 4. Manipulating Jupiter's environment. Having established a floating habitat within Jupiter's atmosphere, our next ambitious goal is to transform the planet's environment into something more hospitable for human life. This process of manipulating Jupiter's atmosphere to create Earth-like conditions represents one of the most audacious terraforming projects ever conceived.